negative 2x. Y is equal to negative 2x. So when we introduce a negative sign, what ends up happening? It's going to change which direction our line is going to go. So yes, now in this case, we are going to go down 2 over 1. Down 2 over 1. Then we can do the same. We go up 2, left 1, up 2, and left 1. All right? So when we introduce a negative sign, our line is decreasing. All right?
Why is it on the other side? It's negative.
Because it's negative.
Oh, okay.
Right?
I don't like it.
This negative 2 makes it go from increasing all the way to being decreasing. All right? So we are going to see if we can use this logic with graphing linear functions to help us understand how quadratics can be changed. Let's make sure the phones are put away, please. All right, so go ahead, flip it over to the next page. All right, we're going to start by looking at what is called a parent graph. All right, so this is called a parent function or graph. Okay, parent function slash graph, and this just means there is nothing else attached to the variable that we're working with. All right, so this is going to be y is equal to x squared. All right, that's what that first box A is saying. Y is equal to x squared. So if we want to go ahead and graph this, we're going to use the table that they have in there. So it's got negative 2, negative 1, 0, 1, and 2 for our x values. All right. So if we plug in negative 2 into x squared, what is that value? Negative 2 into x squared. What's negative 2 times negative 2? It's going to be a positive 4. It's going to be a positive 4. All right? What's negative 1 times negative 1? 1. 0 times 0 is 0. 1 times 1 is 1. And 2 times 2 is 4. So now that we have x and y values, we can come back over here and we can graph what this is going to look like. So we're going to start. So we got 0, 0. We have 1 and 4. Or 1, 1, 1. And then we have 2, 4. And then we can work the other way. So we have negative 1, 1. And negative 2, 4. All right, so when we go ahead and connect these points, does this look like it's going to be a line? No. No. So in this case, we connect them, and it's going to be rounded off at the bottom. So we connect them. We connect them. All right, and it's going to be rounded off at the bottom, and we're going to go back up in the other direction. This shape is called a parabola. It's called a parabola. Right? So when we are working with these functions today, all of them should resemble something like this. All right, so we used the table, and then we plotted the points, and then we rounded off when we graphed it. So when we look at the direction, if I'm coming down in this direction, is that increasing or decreasing?
Decreasing.
That way is decreasing. All right, so that is decreasing. Which means this way is what? Increasing. Increasing. So you will always have an increasing side and a decreasing side. What is special about this point right here? So it's the origin, right? But what what happens at this point right here?
It meets.
Use increasing and decreasing. What's happening here?
It's the lowest point.
It's the lowest point for this graph, right? So this point right here at 0, 0, 0, 0 is what we call the vertex. It's either, in this case, it is the lowest point on our parabola. Now, if I were to draw an imaginary line right here, what is that doing? Yeah, it's being an imaginary line. But what's the shape of the graph on each side of the line? It's symmetrical. It's symmetrical. Now, what would this line be? Like, if we were to write an equation for it, what would it be?
0, 0.
So it would be something is equal
Zero,
to
one.
0. Something is equal to 0.
1.
1 equals.
Is x equal to 0 or is
Y.
y equal to 0?
X and Y.
In this case, x is equal to 0. All right, for this line right here. This line right here, x is equal to 0. All right, and what we call this, I'm glad you used the word symmetrical here. This line, x is equal to 0, is called our axis of symmetry. Axis of symmetry. It's where the parabola gets cut in half. All right, so when we look at the parent function, it's decreasing and then it moves to increasing if the shape is a parabola. We have a vertex, which in this case is our lowest point at 0, 0. And we have an axis of symmetry at x equal to 0. All right, so there's a lot that we can look at with just a function of y is equal to x squared.
And restart it.
So if we move over to b,
Please.
b in this case
Then delete the old one.
is y is equal to 2x squared. When we introduced a coefficient greater than 1 on our line, what ended up happening? What happened on the front page when we had in lines that had a slope greater than 1? Was it steeper or shallower?
It was shallower.
Shallower. So what do we think is going to happen?
You're in times it by 2, 4.
So we're going to multiply all of our values that we had previously by 2. All right, and then what is our parabola going to look like? Is it going to be
It's gonna be
skinnier,
like
or is it going to be
steeper.
out wide?
It'd be out wide.
All right, so we're gonna run with it being out wide, and we're gonna see if that's the case. All right, so using our values that we had in part A, all right, so we're gonna multiply all of them by 2 because that's what we have as our constant here. All right, so in this case, it's going to be 8, 2, 0, 2, and 8. All right, you can get that by just plugging in your x values into your
Would it
equation.
be negative?
No,
I mean,
it would not be. Because remember, when we square a negative number,
oh, yeah.
right, it's a negative times a negative, which gets it positive. All right, so when we go ahead and go and graph this, all right, so when we graph this, right, we'll work from left to right. So our x value is -2, which means we go to the left 2, and we go up 8. Up 8. Right here, we go -1, up 2. We're still at 0, 0. 1, 2, so right 1, up 2. And then 2, over 2, up 8. All right, so remember when we draw this, bring it all the way down.
So it's pretty straight.
Right, so this,
Come, you're wrong.
it is end up being the opposite of what we thought. It's not wider, but in this case, it's a lot more straight, right? So what happens when we have a coefficient greater than 1? So I'm going to refer to this as A, all right? So when A is greater than 1, we have what's called a vertical stretch. All right, so when A is greater than 1, we have a vertical stretch. So think about it with like a piece of gum. When we have a piece of gum and we pull it, right, it's getting skinnier and skinnier as we pull it apart, right? So when we add a coefficient greater than A, it's going to be a skinnier parabola. Now what's our axis of symmetry? Our axis of symmetry, what line divides the parabola in two? It's the same thing as the first one.
X equals 0.
X equals 0, and what's our vertex? 0, 0. Right, so in this case, they're the same exact thing. All right, so we have a vertical stretch from the number out front of x squared is greater than 1. Vertical stretch. Now let's take a look at C.
Alright, let's get it.
So C is 1/2 x squared. 1/2 x squared. So we're still using that same table. All right, so if we plug in -2 into x squared, what's -2 times -2? 4 times 1/2 gives us 2. 1 times -1 is 1. So 1 times 1/2 gives us 1/2 here. 0 times anything is 0. 1 times 1 is 1. And then we multiply it times 1/2. So we get 1/2 here. And then we have 2 squared, which is 4 times 1/2, which gives us 2. So before I go ahead and graph it, we already had one case where we had a vertical stretch, right? So what do we think is going to happen when that first number out front is less than 1?
It's gonna go down. It's gonna go like this.
It's going to be, so you think it's going to be upside down?
Yep.
You think it's going to be upside
It's
down?
upside
Let's
down.
go ahead and see what's going to end up happening.
It's not.
All right? So
It's definitely
I
not.
hear some people saying it's not. We'll see. We'll see.
Oh, and you're so wrong.
Okay, so we have -2, so we're going to go to the left 2. We're going to go up 2. We're going to go to the left of 1. And we're going to go up 1/2.
That's so weird.
We're going to go 0, 0. We're going to go to the right 1 and up 1/2.
moment, cool.
And we're going to go to the right 2 and up 2.
How do you do it?
All right?
You just gotta know
What the?
So
Is it?
Halfway.
in this case, it's not upside down. It's not upside down. But what's the difference between this function and y is equal to x squared? So
Outward
this
facing.
time it's shallower, right? This is what your first prediction was. It's going to be a lot more wider when we draw out our parabola. So when a is less than 1, but also greater than 0, all right? So it has to be a positive fraction. All right, it has to be a positive fraction. We call this a vertical.
Let's find it.
We call this a vertical shrink. I know, right? I'm a math teacher, not an English teacher, you know. Vertical shrink. All right, so when A is between 0 and 1, it's a vertical shrink. Graph is going to be a lot wider when we ride. It's going to look like a bowl, right? It's going to be bowl-shaped. All right? Our axis of symmetry is now what?
The same thing.
That's right. It's the same thing, and our vertex is still 0, 0. Right. All right. We're going to skip D. We're going to skip D. And we're going to go to E.
Guys,
We're going to go to E.
For lunch today, bro. They don't think they're sort of down.
So E,
Wait, we're skipping D.
yeah, we're skipping D. We're going to E. Is negative x squared.
Let's go sideways.
It's going to be negative x squared. So you're thinking it's going to be sideways?
No.
You think it's going to be like that?
What?
No.
Jacob, what are you
Is
talking
that what you're saying?
Logan.
It's gonna be upside down.
All right, we'll run with that. We'll run with that. We'll see. Sideways. So we got x, y. All right, so we got -2, -1, 0, 1, and 2. We're going to do the same exact thing that we've been doing. So we have -2 times -2, which is 4, but in this case, what's out front? Negative, so it's gonna be a
Negative.
-4. -1 times -1 is
What's going on here?
1
Negative
times
1.
-1.
Where are we at, Cole?
All right. So we're plugging in our x values into here. Okay. So what this is saying is we're going to take -2 squared. All right. So what this is doing is we have a negative. We have -2 times -2. So what's -2 times -2?
You know what?
That's 4, right? We're gonna have a -4. All right, so that's where this -4 is coming from. So all that we're doing is the equation that we're given, is we're plugging in these x values, and we're trying to get the y value. Does that make a little more sense?
So the x, or so the
We still got 4
x
minutes.
value is what you times it by?
Yeah, so the x value, right, so in our table, right, it has x and y. All right, we're just plugging in our x value into here.
Oh,
Right.
okay.
So like in this case, if we plugged in 0, we would have -0 squared,
Yeah.
right, which is equal to -0 times 0.
Easy ways to figure this out.
But what's 0 times 0?
Watch.
It's
Zero.
just 0, right? So this is -0, but which is the
No.
same case, right?
fine.
-0 and +0 are the same thing. So that's 0. All right,
Reader's
let's do the same
definition.
thing with this 1. So we're gonna plug in 1
Logan.
over here. So what's 1 times 1? 1, but we have
Add
to
the
factor
negative.
this
-1.
So we got -1. And now we
You know
have
what?
2, right? So we have, plug it in here, we get 4 times -1, which
Negative
gives
4.
us -4.
So nice.
All right,
Shut up.
all right.
It's
So
gonna
we're
be
gonna
upside
go
down.
ahead. We're gonna go ahead and graph this.
You're such a dick.
Whoa.
Get that on camera, man.
Come on now, I'm recording here, dude.
Yeah, come on.
What are we doing? Come on now. That's all right. Okay, so when we graph this.
We'll edit that out.
Yeah, when we graph this.
Better at it.
When we graph this, we're going to take -2, so we are going to go to the left 2. But instead of going up 4, what are we gonna do?
Down.
We're gonna go down 4. We're gonna go down 4. We're gonna go to the left 1 now, left 1. Down, okay. 0, 0 is our origin.
Get the delete button.
Now we're gonna go to the right 1 and down 1. And we're gonna go to the right 2 and down 4. So in this case, it's not going to be sideways, but people were saying it's going to be upside down, which now is the case, it's going to be upside down.
Colin, it's all your fault.
Now, when we look at this upside down parabola, all right, is this side increasing or decreasing?
Decreasing. It's increasing.
It's
Increasing, 'cause it goes
increasing
up
now.
to the 0.
Yep,
Just decreasing.
increasing.
In value.
So this other side is decreasing, all right? Now, since it's flipped upside down,